Hi, now we want to discuss about the final part of engineering immunity, but this is a bonus as we're gonna talk about innate and adaptive immunity. This is a review. So at the start, I want to show you this a very interesting movie again for tracking of mobile cells, which is immune cells here in the dermis, which is underneath the skin after skin irritation. So what you can see over here, these are big round ones are hair follicles. Outside is a tissue containing like blood vessel and connective tissues. And what I want you to focus is for this 25 minutes, little faster movement, how hard and how diligent our immune systems and cells are working. So let's take a look. You see these little cells, and these immune cells are working hard over the time. So they come back and forth, come in and out of a blood vessel and inside tissue. So looking for, I think this is a process kind of inflammation. So whenever there is any insult, in this case, skin irritation was done by putting a tape and then detach. So over this, there's some minor skin irritation, and our immune cells are actively responding to it. So what are the differences between innate and adaptive immunity? So first, let's start from innate. So innate immunity is to help destroy pathogens, including like bacteria or virus or something else outside of our body before they can infect our whole cell. So this is really the first line of defense. That means very early stage, and so our body immune response should be fast. And at the same time, this is a kind of a non-specific, meaning that we only recognize of very common molecular component, mainly expressed or shown by, let's say, bacteria. So for example, is LPS or lipopolysaccharides, and these are gram-negative bacteria outer membrane have this component. So our system, probably immunologically developed, our innate immune cells such as macrophage or neutrophils will see LPS, then they directly attack this external attack. So in that regards, so this innate immunity do not have a memory, which memory means once you have an invasion from outside, you remember that so that we can prepare for the future insult. And in the future, we gain faster and faster. But this innate immunity is irrelevant for the memory. So it's more related to when these invasion happens, we produce a general inflammation, which is representative by like 4 phenomena. One is heat, so the temperature goes up, you all remember, and vasodilation, which is a enlargement of the blood vessel, so that, and lymphatic vessel probably, so that the vessel will dilate, and also it involves the pain. So we know that there are something happening there. So it gives a signal to our brain and ourselves, and also because of probably vasodilation, and there's a swelling, which is an exudate of a plasma into the tissue, so the tissue will swell. So these 4 phenomena probably helps us to protect ourselves from this invasion. So the component of this innate immunity, there are, I already discussed about a complement system, which starts from C1 to C9. And whenever there's an external one, it's inside this blood plasma, they see these foreign cells, the complement goes in and then make a pore so that it actually lyses those bacteria. So, and another component of innate immunity is white blood cells containing macrophages, neutrophils, and NK cell or natural killer cells. So these cells are more like general innate immune cells. So what are the limitations of our innate immunity? Is they are very quick, they are non-specific, no memory, but they are not as always effective. And they may fail to clear the pathogen before infection is establishing. So we have a more elaborate system, which is slower, but adaptive to our the external invasion.